A rowing team rowed 900 miles while going with the current in the same amount of time as it took to row 10 miles going against the current. The rate of the current was 4 miles per hour. Find the rate of the rowing team in still water. Now, I know a lot of textbooks like to make tables and stuff for this kind of thing, but I don't know. I just kind of imagine myself in the rowboat, or actually, it's a rowing team. And then I think about my childhood, and I can remember being in a canoe. And if you were canoeing with the current, you didn't have to paddle very hard. The current just kind of took you with it. But if you turned around and tried to paddle upstream, you really had to work hard to get the boat to move. Same thing happened when I was on my bike on a windy day. If I was riding with the wind, it was like, whee, I'm having a big time. But if I turned around and tried to ride into the wind, I really had to pedal harder. So the current in this case, or the wind, if they're talking about a plane flying with the wind and against the wind, it's the same thing as with water, going with the current and against the current. If you're going with the current, it actually speeds you up. If you go against the current, it actually slows you down. And in any of these problems, there is a formula that you need to remember, and that formula is simply D equals RT, where D is distance, R is rate, and T is time. And if you drive a car, you should know this. The distance that you travel is going to equal the rate or the speed your car is going times the amount of time. So if you get in your car and you get it up to 70 miles per hour and you put it on cruise and then you go for 70 miles per hour for 3 hours, 70 times 3, you will have gone 210 miles. So anywho, when I'm reading this problem, however, I have two different distances. They go 90 miles with the current, but 10 miles when they're going against it. And the only thing I know for sure is the rate of the current is 4 miles per hour. And there is one key thing. I'm going to use my highlighter here. It says the same amount of time. The rowing team rowed 90 miles while going with the current in the same amount of time as it took to row 10 miles against the current. Now, whenever I'm doing algebra, I'm dealing with equations. There's got to be an equal sign somewhere. And right there's my equal sign. It tells me that the time that they rowed when they were going with the current, I'll use W for with, is equal to the time that they took to row 10 miles against the current. All right. So I know something is equal. The time with equals the time against. Now this formula up here, this guy, distance equals rate times time, is solved for distance. Since my equation over here has time in it, I want to solve this for time. So over here, I'm simply going to say, all right, if distance equals rate times time, what would time equal? Well, to solve for time, I'll divide off the R. Because when you divide off the R cancels out over here, and you're just left with T. So T, time, is the same thing as your distance divided by your rate. And I know those things. I know the distance they went with the current, that was 90 miles. I know the distance they went against the current, that was 10 miles. And then the rate that I know is actually of the current. The current itself is 4 miles per hour. What they want us to find is find, I'll use a different color here, find the rate of the rowing team in still water. Okay? All right, so back to my equation here. Instead of having the time going with the current, I will say I want the distance with the current divided by the rate that they're traveling with the current. And the same thing on the other side. I want the distance going against the current divided by the rate going against the current. And I already know two of those amounts. I was told that the rowing team rowed 90 miles while going with the current. So 90 miles goes right here. I was also told it took 10 miles going against the current. So the distance against was 10. And then they tell me that the current itself was 4 miles per hour. But here is where, when I was talking about, as a kid, canoeing or riding my bike, when you are looking at this right here, if I'm looking at the rate at which they are rowing with the current, I'm looking for the rate R in still water. But the rate they go with the current, remember the current, if you're going with the current or riding your bike with the wind, that's going to speed you up. And it's going to speed me up by 4 miles per hour. And then whatever your rate is in still water, if you're now going against the current, that current is going to slow you down. And since the current is going 4 miles per hour, it's going to slow me down by that much. Remember, R is the rate of the rowing team in still water. Just how hard can they paddle? But if you bring in a current and they're going with the current and they keep paddling at the same rate, the current's going to speed them up by 4 miles per hour. If they turn around and paddle at the same rate, that current's going to slow them down by 4 miles per hour. And that's my equation, which is a proportion. And as I talked about in my announcement about proportions, there's a property about proportions that says that the cross products are equal. So all I'm going to have to do is multiply this cross product 90 times. I'm going to take the 90 times the R minus 4. And that is going to equal the other cross product of 10 times R plus 4. And then I'm just going to distribute to get rid of my parentheses on both sides. First, I'll distribute the 90. That's going to give me 90R minus 360. And then on the other side, I'll distribute the 10 over here. That's going to give me 10R plus 40. And now I need to get all my R's on one side. So I'm going to subtract 10R from this side, which means I'll subtract it from the 90R on the left. And if you don't mind, in the same breath, I'm going to get all my non-R's on the other side. So this minus 360, I'm going to add a 360 to it to cancel that out, which means I'll have to add 360 over here. So 90 R's, take away 10 R's, leaves me with 80 R equals, and on the other side, 40 plus 360 is 400. And then the last step is just going to be divide off the 80, so that 80 divided by 80 cancels. And when I divide 80 on the other side, I get a rate of 400 divided by 80 is 5. This rowing team is rowing at a rate of 5 miles per hour.